When you try to put a magnetic field through this, there's a superconductor inside of this. While it's superconducting, basically the magnetic field's going to come up and go, the superconductor will say, no, that magnetic field bad. And it will go around. It'll actually create its own magnetic field that directly cancels it. However, with a special type of superconductor called a type 2 superconductor, there's little tiny holes in the material. This usually happens like with defects. If you had a crystal lattice, atom, and then there was one missing, there's like a hole there. So it actually turns out a little bit of the magnetic field can go through in a very understood quantized way. So it has like this very rigid structure that's like, it pins it there. So like literally imagine a piece of string through this thing. That's the magnetic field, and so it will hold it there like that. And so it'll make this thing float and like defy gravity, which is pretty cool to watch. This was a very big deal when this was discovered. It sort of like broke physics when it happened because no one thought that this would do like what it does basically. So it was very exciting. We'll start off with probably like the funnest, I think this is like the coolest thing ever. So this isn't like, if you get two magnets, right, you put a north magnet by a north magnet, it sort of floats. Like, I'm sure everyone's played with a magnet before enough to know that. That's not what's happening here. So if you put a magnet on here, right, like a magnet, it was floating, and I flipped it over, it would shoot off because of gravity. That's not what's going to happen. So if we pin this on here, you can see that it levitates, but this is the cooler part. When you flip it over, it stays there. So it fully doesn't care because, like I said, there's literally a piece of string poking through this that's holding it there, so to say. And so you can do other much more fun experiments with this. This one's kind of cool. This is a circular magnet, so you can spin it, and it like, this is you could, in principle, like make frictionless bearings and stuff out of this, but that's a long ways off in technology. But my funnest part of this demo is you can put them on this track, and it will spin around in a circle for... There's a really cool video on YouTube, if you guys actually are interested in this, where they do this inside of a vacuum chamber. So the only reason this will slow down is because it warms up and stops superconducting, or because of air resistance. They do this inside of a vacuum chamber, and it's cold in the vacuum chamber. And they let it go for like 10 hours and time-lapse it. And so it like really will go forever until it warms up, which is pretty, I would say, amazing that that happens.